the position vector AB and AC, then determine the angle between cable AB and cable AC. I have already written the equation that we will use to solve part A of this problem, which is finding the position vector for AB and AC. The easy way to solve this problem is first to write the coordinates for the corners that is asked for. So corner A or end A and B for AB, and also C for AC. So I start with A. I'm going to write the coordinates for A and then B. By looking at point A, you can see that it's on ZY plane. It means that it doesn't have any X coordinate, or its X coordinate is 0. So 0 XY, long Y it's 4 meter, and long Z it's 3 meter. So the coordinates for A is 0, 4, and 3. Now for point B or end B, it's here. We can see that long X, it has moved 1.5 meters, so 1.5. Long Y it's 0, and long Z it's 6 meter. Now that I have these two guys, I can write R, or position vector for A, B, using this equation that I have provided in here. It's going to be XB minus XA. So it's 1.5 minus 0 in I direction, plus YB, which is 0, minus YA, which is 4 in J direction, plus ZB, which is 6 minus 3 in J direction. That means that RAB is equal 1.5I minus 4J and plus 3K. Easy. I can use this to find the magnitude of RAB. So the magnitude of RAB is square root of squares. You know this equation. So 1.5 square plus negative 4 square plus 3 square. And if you solve it, you will get something around 5.2 meter. So cable AB is 5.2 meter, and its vector or position vector is 1.5I minus 4J and 3K. We have to follow the same procedure for AC. I'm going to write A again so that we don't make mistakes. So I transfer A from top to here. So it's 4, 0, 4, and 3. Now I write C underneath that, and C is this guy in here. C, its X is negative 2 because positive X is in this direction, and you can see that it's in the opposite of X direction. So it's negative 2. Its Y again is 0, and its Z is 4. By looking at this drawing, this is 4. Therefore, again, the same procedure. R, this time is AC, is I'm not going to write because the whole equation, because you just can look at it and say that X is negative 2I, then 0 minus 4 is negative 4J, and 4 minus 3 is plus 1, which I'm not writing 1, k. So this is position vector for AC, and from there I can find the magnitude of AC using again square root of squares. So negative 2 square plus negative 4 square plus 1 square. And again, if you solve this, it's the square root of 21, and that's 4.6 meter. Now we have RAC as a vector and RAC as magnitude or scalar, the length of RAC. Now the second part is asking for the angle between AC and AB, these two cables. So if I erase this, so it's asking for this theta that we have here. So it's asking for this theta. In order to find the theta, we use dot product. So we use dot product in order to find the angle between two vectors. Don't forget, in some problems, they may not give a part, or they may not ask you first find vector AB and AC. They may ask you directly find the angle between the two vectors. So the procedure is the same. First you have to find the vectors, and then using dot product you can find the angle. Second thing that I have to mention is that you can find angle between any vectors. For example, you can find angle between this vector and this vector. It doesn't matter if it's a position vector or if it's force vector. You can find between any vectors. Now, from this equation, I have this part. This is the magnitude that I calculated here. It's 5.2. And also I have this part, which is 4.6. I don't have these guys, but you know that RAB dot RAC is equal. For dot product, if you review your book, it's just I components time I component, J component time J, and K component times K. So it's 1.5 times negative 2. So 1.5 from here, negative 2 from here. So 1.5 times negative 2 plus negative 4 from here and negative 4 from here. So negative 4 times negative 4 plus K component 3 times 1. So 3 times 1, and that's going to be negative 3 plus 16 plus 3, and it's equal to 16. Therefore, theta is cosine reverse. So we calculated RAB times RAC, which is 16, divided to RAB is 5.2 times 4.6. And if you solve it, it's going to be around 48 degrees. This is theta that we are looking for. Don't forget, I dot I is 1, and it's equal to J dot J, and that's equal to K dot K. That's why we just multiplied I components to each other, J components to each other, and K components. But I dot J is 0, and the same is as J dot K, and the same is K dot I. Therefore, the other components, when they multiply them to each other, it becomes 0.